The problem from GATE Physics 2012 reads as follows. Consider the following op-amp circuit, and we have been shown a circuit, and the problem asks which one of the following correctly represents the output V out corresponding to the input V in. We are given four options in which the input voltage rises from 0 volts to plus 5 volts, and we are required to find the output, what is the output waveform, the correct output waveform corresponding to the given input waveform. Whenever you encounter a problem related to op-amp, we must always ask ourselves a few questions. First, is this an ideal op-amp? If the question is silent about it, assume it to be ideal. Second, check if there is a feedback. Feedback present. So in this question, we see that the output node is not being fed to any of the inputs. Hence, we say that feedback present as no. Now, when there is not any feedback present, typically the circuit is a form of a comparator circuit, and we have seen that in the theory that we visited. So now this is an example that now we'll try to solve the same circuit that we saw. Now we'll try to solve a problem related to the comparator circuit. Now, right. So first we need to find what the voltage of this node is. Let's assume the voltage of this node is Vx. I'm just giving it a name. It doesn't matter. So let's find the value of Vx now. Let's assume a current I is flowing through this loop. Now, please understand, so this is an ideal op-amp. No current will be flowing inside here. So I plus equal to 0. No current will be flowing in here. So I minus equal to 0. And obviously no current will be flowing out since there's no load connected. So I out will be also be equal to 0. Right. So whatever current is coming is fed by this voltage source will follow this path and go to the ground here. So we can find this is nothing but a voltage divider. Now we can simply write the value of Vx is nothing but 1 kilo ohm divided by 1 kilo ohm plus 4 kilo ohm times the input voltage, that is 5 volts. So this will come out to be 1 by 5, 1k by 5k into 5 volts, which is nothing but 1 volts. So this node, the value of Vx is nothing but 1 volts. Now this Vx will serve as the reference node. Note that this is the input, this is the inverting input to the operational amplifier. Now this node Vin will be compared to this voltage. So we can say that whenever Vin is greater than Vx, remember the expression for an operational amplifier, it is V out equal to AOL V plus minus V minus. Now if Vin is greater than Vx, so this is the case 1. Case 1, when Vin is greater than Vx, this implies V out will be AOL times some positive quantity. So this will eventually saturate to plus Vsat. Now we know the plus Vsat is 10 volts, so we can simply write this as plus 10 volts. So V out when Vin is greater than Vx, and we have calculated the value of Vx, which is 1 volts. So whenever Vin is higher than 1 volts, the output voltage should be 10. Now let's try to plot this. So whenever Vin is greater than 1 volts, so whenever Vin, so from this point onwards, so this region, Vin is greater than 1 volt, so our output should be 10 volts. So our output should be 10 volts, our output is 10 volts. So this might be a correct option. So this Vin is greater than 1, the output should be 10. No, this is wrong. This is not correct. So this might be correct because 1 volt would be somewhere here, right? 1 volt, and this is higher from this region. This cannot be correct. Right, now let's look at case 2. Case 2 is when V in is less than Vx, which is 1 volts. Remember that we have already calculated the value of Vx. So we get V out equal to AOL times, now V in is less than Vx, so this quantity is negative, which is equal to minus Vsat, which in this case is minus 10 volts. So when V in is less than 1 volts, value of V out should be minus 10. So when V in is less than 1 volts, this means in this region the value of V out should be minus 10. So value of V out should be minus 10. So this is the correct option. This matches both the regions for greater than 1 volts and for less than 1 volts. So A is a correct option. Thank you for listening.